how these computers works. Now let's talk about first classical computer. Which uses bits 0 or 1. So this is a system, computer system, which use the input value and will get the output. Input and output. So it will be takes only 0 or 1 value. Only one value. Now, to execute or to solve any problem, let's take example 2 plus 3 equal to 5. Okay. Now, normally how we will write? Load 2 value. First we are entering loading 2 value inside. Next, load 3 value. Second time we are loading 3 value. Now we have to do operation add. So already these 2 values are there inside the computer. Now we are giving the command add, and now store. That is 5. Just I written simple so that you can understand easily. What? Like this total we call as a program. Understood? Program means group of instructions. Each one we call as a instruction. Understood? Program is a group of instructions. Understood? So every instruction we are giving a command to the system, means to the computer, do that. So first what I am saying is what I am telling to the computer, you giving the command, just I am saying that load 2 value inside that. So it loads 2 value first. Now next load 3 value. Loading 3 value. Next, saying about add, and store that value 5. That will be. Understood? So what is here? Step by step. That is the main concept. For that purpose, I am explaining this program. So this system will work simultaneously. Or step-by-step process. Understood? So this is the language we can call as assembly language. Because we are using English and so the assembly language. Actually, what computer understands only 0 and 1 only. As we talked about the components, each component is having 0 and 1 value. So using that 0 and 1 only, system can understand. So you have to write a commands in that manner only, using zeros and ones. Now I will write. Load. Let's say I write 0, 0, 0, 0, that is load, and 2 is, let's write 0, 0, 1, 0. Next again load, so 0, 0, 0, 0, and 3 value, 0, 0, 1, 1. Now add, maybe some instruction, just some code, that is the add command. And this will be the store. Maybe store will be the 1, 1, 1, 1. Store that will 5, 0, 1, 0. Now understood, this is which can understand by the computer because all are in zeros and ones only. Understood? So this one we call as a binary language. Understood? System understands only zeros and ones. That's why to do our problem, we have to write commands or we have to write a program using binary language. Why binary language? See here by. By means two-wire. Understood? By means two. What is two? Here only 0 and 1. These are two values. Got it? So using 0 and 1, writing a program or writing a instruction to the computer. So this total we call as a binary language. Now this is our understandable form. System unable to understand what it is. So this language has to be converted into binary language. This language has to convert it into binary language. Then only system will do it. Understood? So, now what languages we are having? First, system understandable language is binary. Binary language using zeros and ones. This you call as a low level language. Means it is neither to the computer. Can you write a program all in zeros and ones? It's very difficult for us. Remembering all the commands, for example, add. How we written add 0, 0, 1, 1, 1 like that. Or subtraction 1, 0, 0. Multiplication 1, 1, 1, 1. So it's very difficult to remember all those things and to give the instructions to the computer to solve the problem. Isn't it? So that's why we are using later, after binary language, we came to the human understandable language. Language that is assembly. So human understandable language means Telugu, English or but best is language, international language, so English only we are using. So using English language, giving commands to the computer. So what I written in the last, like load is English word, load 2, load 3, add and store 5. So when compared with binary language, it is a little bit better. Understood? So this is assembly language. This is middle language also we can say. Because this language is middle because between ourselves and computer. What? No. Even for writing complex problems, you have to write number of lines. Program will be lengthy. So every time loading like this, writing commands is very difficult. So came to the high level languages. Like C language or C++, Java, Python, etc. These are high level languages. So lengthy program also you can write in short and easy to write or easy to write commands or instructions when compared with the assembly language. Assembly language is better instead of writing binary language because binary language is very difficult for us. So this way computer language are developed. So even if you write this program high level language, it will be converted into assembly language and assembly language will be converted into binary language, means translation. Even otherwise directly you can write using high level language to the binary language. What it will be? Our language has to be translated into machine level language. So machine level language is binary. Understood? Our languages you can say C or C++, Java or Python. Understood? These are languages are to be translated into binary language. Then only system is going to work. Understood? So here main concept you have to remember. That is in classical computer we are going to write a program or we are giving the instruction that as if it is going to take step-by-step process or simultaneous. So this is the main concept you remember, one by one. Understood? Now when coming to the quantum computer, what it will take? It will take input information as qubits. Qubits are zeros and ones only, but it takes multiple values. Here is single. Classical computer will take single value. Here quantum computer using qubits it will take multiple values at a time. Understood? Here last time I explained that the load A, load B, load like that, one by one instruction. There one by one step by step. Here at a time it will take all the values, multiple values. Let's say add 2, 3, let's say C. Or simply A, B, C. All this program, what we done, 2 plus 3 equal to 5. This program will get in one step. What we are saying, A value 2, B value is 3. So this command will instruct the computer, means quantum computer, add A and B value, store into C. Single, one instruction, one line. Here it's taken 4 steps. Understood? So, main concept here is single, step by step or simultaneous process. In quantum computer uses qubits, takes multiple values. It will process parallel. Or sequential. Means all process will go parallel, sequential like that. At a time, it will go into do process. Understood? That is the main concept you remember in this. Classical computer is simultaneous process, quantum computer is sequential process or parallel process. Hope you understood. So, quantum computer, which uses principles of mechanics. What are the principles of mechanics? That is superposition. Second one is entanglement, and third one is interference. Remember these three is very important. So these three we can say as simply basic principles of quantum computers. So if you want to solve any type of problem in quantum computers, we have to utilize these three principles. Understood? Now, let's know the principles of quantum computer. What are the principles? Mechanical principles that are superposition, entanglement, interference. These are the three principles used by the quantum computer. Understood? Now, let's discuss about superposition. So, quantum computer is qubits. It means two values. Now, let's see 0 and 1, two values. Goes inside the computer, quantum computer. What is first one? Superposition. So, the 0 and 2 value, first it goes to the superposition. How superposition is? Two values. It has to go two values at a time inside the superposition. Let's use example. Let's see. This is head value. You can see it. It is a head. Let's take one value. Now second side is a 0 value, like a tail. Now if I give like this, only one value. Am I right? If I give like this, only one value, that is 1. So I want both at a time. Means quantum computer want to take at a time both values. So only thing is, if I make it like this, what you see, the coin is rotating. You can't see either 0 or 1 state. Both are rotating. It is, coin is in multiple state. Not 0, not 1. Understood? So, when you are in multiple states, not single state, multiple positions or multiple states, we call as a superposition. Understood? Multiple state. That time we can't say which position you are. Okay, let's say you one example. Myself, I am driving a car. That is one word, driving a car. But while driving a car, I am speaking with other person phone. So while driving a car, using phone also. So what is my position that time? Driving, one position. Second one is chatting with phone. So at that time, I am driving and also talking with someone through phone. So I am in multiple states. If anybody asks what he is doing, can you say he is driving? Or can you say he is talking phone? Not single, both at a time he is doing. Understood? That is superposition. When it is in multiple state, you can't define that is in particular state. Even if you take a coin, okay, head, and this is tail. If I give like this, only one value. Understood? Like this. If I flip this coin, it rotates. It rotates means there is no head, no tail. Rotating. You can't say that is particularly this coin is in head state or particularly the coin is in tail state. It rotates. Now see, if I say like this, rotating means the coin is not a particular state. Understood? So that is you call as a superposition. Hope you understood.